All right, here we are. We're in Chapter 12, Client Hyper-V. Now, we've been dealing with Hyper-V for a while because one of the things I showed you a video of back in, I think it was either Unit 1 or Unit 2, how to go use the virtual machine that exists with Win10, and we can actually go create a Hyper-V instance on that virtual machine. Hyper-V, let's go talk about it here. After we're done with this, you're going to understand how Hyper-V works and how to install it. You're going to create virtual machines, configure virtual memory, configure virtual processors, create and manage virtual hard disks, configure virtual network adapters, and manage virtual machines. Now, what is Hyper-V? Virtualization allows the hardware of a single computer to be shared by multiple operating systems running at the same time. Hardware capacity is subdivided into virtual machines, each of which is allocated a specific amount of resources. After creating a virtual machine, or a VM, the OS is installed and the VM behaves just like a physical computer. Now, hypervisor, it resides on the operating system and hardware and controls all communication with the physical hardware on the computer. Now, the host operating system, in this it's Windows 10. The hardware drivers for this physical computer are loaded there. Consider the parent partition. Each of the VMs is a child partition. So when we look at it, here's the hardware. We've got hypervisor, parent partition, child partition, another child partition. Okay. So here's our Win10 instance. It'll deal with hypervisor that manages all of this. The VMs do not have access to any physical hardware, not directly. You don't load the drivers for the hardware on the physical machine, and VMs do not have access to virtualized hardware provided by Hyper-V. Now, recent Windows operating systems include drivers for virtual components called integration services. Now, we've got scenarios for using virtualization. For computers running Windows 10, Client Hyper-V is more likely to be used for testing or application compatibility. Client Hyper-V, we can update testing and software testing, software deployment, demonstrations, training, app compatibility, and the big one is running alternate operating systems. We can run an instance of Windows Server 2016 on a Win10 virtual on Win10 using Hyper-V and creating a virtual machine. You can run Windows 95 virtually on Win10. Client Hyper-V in Windows 10 includes support for nested virtualization, so I can have a Windows 10 machine running virtually on a Windows 10 machine, and that virtual machine have Hyper-V enabled on it with multiple virtual machines on it. It allows for a single physical computer enabled as a Hyper-V host to have a VM that's also enabled as a Hyper-V host. Now, that's the difference between client and server Hyper-V. A VM created on a Windows server can be moved to a client Hyper-V and vice versa. Features in Hyper-V for Windows Server not available in client Hyper-V. We've got live virtual machine migration and Hyper-V replica. Client Hyper-V for Windows 10 has one feature that's not available in Hyper-V for Windows Server. It supports sleep and hibernate functionality in the host OS. Client Hyper-V prerequisites. When it comes to Client Hyper-V, it's not included in Windows Home or Windows Mobile editions, nor is it supported in 32-bit editions of Windows 10. Now, it requires 64-bit with second-level address translation, processor support for VM monitor mode extension, and it also requires virtualization enabled in the firmware, and hardware enforced data execution prevention, DEP. Now, you can run system info to confirm that it meets the Hyper-V requirements to be able to run. If I want to install client Hyper-V, you can install it using a GUI, using PowerShell, or DISM. Once it's installed, you may have to reboot it depending on how you're going about it. Now, the first thing that we'll start doing, let's do it doing a GUI. You can go down to Cortana and type in turn Windows features. It'll come up and that'll give us this turn Windows features on and off option, and that GUI will pop up. We'll select Hyper-V, the highest level of Hyper-V, and by checking Hyper-V, all those subsets will also get selected. Then we just click OK. That will allow Hyper-V to run on our machine. When we're creating virtual machines, we need to take into account the memory, the CPU, the disks, and the network. So here's Hyper-V Manager up and running. And this already has a virtual machine installed. We see VM1. The status of that virtual machine is it's running. It's not using any CPU. We can see how much memory is allocated to it, how long it's been up, the status. There's a bunch of information we can have. Now, if we wanted to, we can create a checkpoint for that virtual machine, and we'll deal with those things as we move forward. So we've got virtual switches that we can create that provide network connectivity for virtual machines. In Hyper-V Manager, you use Virtual Switch Manager to create and manage virtual switches. That'll help us connect to an external network. So here we are, Virtual Switch Manager, connect to a virtual network, and that'll get us right on out. Virtual switches, we can have private or internal or external. When you create a VM, you're given a choice between Gen 1 or Gen 2. Possible states for virtual machines: off, starting, running, paused, or saved. Let me back up. The generations, what's the difference? I popped right through this. Now, we've got Gen 1 BIOS based, Gen 2 UEFI based. Gen 1 not available for secure boot by default in Gen 2. So we got to look at the hardware that we're using. Is the host compatible with these? What's the virtual machine? How do we want that set up? So there's things that we've got to take into consideration. One of the things I found when I'm going to set up, let's say a Linux box. If I'm creating an instance of Ubuntu or Kali Linux, if I try to do a Gen 2, it's not going to work well. If I do a Gen 1 for Ubuntu or Kali, either one of the Linux OSs, I can fly right through it, no worries, and it's all set up. So we need to know what it is we're doing, what the requirements are before we go through it. All right. So virtual machine is much like a real machine. It's either off, it's in the process of starting up, it's running, it's paused. All right. So we need to keep that in consideration. If you start up a virtual machine, shut it down when you're done. Don't just shut down the Hyper-V Manager and leave that thing up and running. It may not be there in the state that you wanted it to be in when you come back. So when you're done with something, it's like I tell my son, when you're done with your toys, put them away. When you're done with your virtual machine, shut it down. Okay. So here we are, we've got a virtual machine, it's up and running, and we see the desktop. We got the controls across the top. All right. Pause, run, stop. All right. Virtual machine connection can be used to interact with the GUI, start, pause, save, shut down the VM. We can change the ISO mounted to the DB drive itself, create checkpoints and revert to the previous checkpoint. Okay. Supported OSs for Hyper-V in Win 10. Vista Server, major distributions of Linux. We talked about that a little bit ago. Now, I can also run Win 10, Server 12, 2016 server. So there's a lot that we can do in there. Okay. Pop on through. Let me come back. So when it comes to settings for the virtual machine itself, how it starts up, how you go about it, we've got that option there. Automatic start actions. The memory itself. Now, if I allocate memory or storage space for a virtual machine, I need to know what the operating system requires when I'm saying here's how much RAM I'm going to associate with it, or how much storage space I'm going to associate with it. And if I'm reserving memory for a virtual machine, there's two ways I can set that up. I can set it up as a fixed allocation of space or a dynamic allocation of space. Both of them, I'll set how much space it is. So let's say I want to reserve 2 gig for my virtual machine. I can say 2 gig static, that is 2 gig allocated only for my VM now. Nothing else can use that space. Or I can say 2 gig dynamic, and my virtual machine can use up to 2 gig, but that space can be shared until such time as the VM needs it. Okay. Here we are dealing with the memory, whether it's dynamic or not, how much memory, maximum RAM, minimum RAM. Do I enable dynamic? Okay. I can have virtual processors. I can have multi-processors in my virtual machine, even though my host machine only has a single processor. It's awesome what we're able to do with this. Multi-threading as well. How many processors? Go right on down the line, how we're configuring our machine. Okay? We can create virtual hard disks. Catch is, if I've got a virtual hard disk, let's assume I have a 500 gig hard disk on my host machine. And I decide I want to create a 500 gig hard disk on my virtual machine. That's all well and good. But that doesn't mean that I will actually have 500 gig of usable space on my virtual hard disk. I only have as much as is available on the actual host machine. All right. So yeah, you may, oh, look, I've got a terabyte on my virtual machine, but I only have a 500 gig on my actual, or no, a terabyte on my VM, but I've only got 500 gig on my host. It'll let you set it up. Does that mean you can store more on your virtual machine than physically exists? No, it doesn't. Okay. Now, Gen 2 VMs use only SCSI controllers for storage devices. You can move disks between IDE and SCSI, and there's no impact on it. Here's something talked about. Okay. If I've got a hard disk, I can edit the hard disk. I can compact it, convert it, expand it, shrink it, merge it, and reconnect it. And that's all done through the menu on the right side, the virtual hard disk editing interface. I can create a virtual LAN or a virtual network in Hyper-V. We can set up multiple systems. I can create a server and define if it's got Active Directory, DHCP, whatever it may be. I can have a virtual switch. It's a number of different physical topologies that we can set up that aren't actual physically there, that's all virtual. So I can have my virtual network set up. There's so much that we can do using these virtual networks now. Now, I can import or export virtual machines. I can make a copy of my VM. One of the things you need to keep in mind, how big these things are. Now, the virtual machine has the entire operating system on it. So it may be 5 gig or more. If you run a 2016 server, that's going to be a big file. The checkpoints aren't as big, but the entire virtual machine is. So we've got to take into account how big that thing is if we're wanting to copy that VM and how we're going to transport that copy, what we're going to do with it. Okay. So we'll go through exporting and importing virtual machines and create the checkpoints. And it's like a restore point in Win10, but it's a checkpoint for our virtual machine. So let's say you've gone and you want to use Hyper-V as a test environment to go create policies and modify a system. We'll set our baseline. Once this system's up and running, just like our baselines when we were doing performance monitoring, we'll set a baseline, which is our checkpoint. So here is the stable system the way we want it. And if anything goes bad, we've always got this checkpoint to go back to. We label it, identify it, we know what that checkpoint is, and we can have multiple checkpoints. And they don't go away like restore points when you go back to a previous version. So it could be different versions of this virtual machine based on the different checkpoints. Let me go to this checkpoint. Now I know what that status is. Let me go to this checkpoint. Oh, it's configured a different way now. So checkpoints are a great resource when it comes to VMs. Once you've created the checkpoints, they're all listed down at the bottom. And here we are. Here's our checkpoints, the different cases. Okay. So we can get the following options for a checkpoint: settings, apply, export, rename, delete checkpoint, or delete the checkpoint subtree. So when it comes to Hyper-V, Client Hyper-V allows you to run virtual machines using a computer with Windows 10. Not just any Windows 10. It doesn't run on Windows 10 Home. You create virtual switches to allow virtual machines to perform network communication. Virtual machines can be Gen 1 or Gen 2. Virtual machine behaves like a physical computer. Integration services provided drivers to the OS in the virtual machine. In most cases, it's beneficial to use dynamic memory to optimize the amount of memory used by the VM, and you're not tying it all up for a virtual machine and taking it away from the host machine. Virtual hard disks can be either the VHD or the VHDX format. If your network uses VLANs, you can configure a virtual network card to allow max spoofing if you're using advanced network technologies such as Windows Network Load Balancing in your virtual machines. You can move virtual machine storage even while the virtual machine is running. So Hyper-V and virtual machines, this is going to be a game changer for us in academics. You'll see in different labs and different courses that we're utilizing it more and more to help us get away from removable drives and be able to create things virtually. Once you set that checkpoint, it works so much better than the restore points that we've been dealing with in the past. So we'll see you in the next one.